You are welcome to our online physics lecture series. Today we are going to solve a question from UTME 2017 Physics CBT. Question number 3. The question says, a string of length 5 meters is extended by 0.04 meter when a load of 0.8 kilogram is suspended at the end. How far will it extend if a force of 16 Newton is applied? Acceleration due to gravity is 10 meter per second squared. So, looking at this question, this is a question of elasticity. For us to be able to solve this question, we need to apply Hooke's law. Hooke's law. In Hooke's law, when you have a string, and you apply a load, or we call it deformation force on it, it will extend at a particular length or displacement. If you remove the deformation force, it will come back to its normal form, provided that the elastic limit is not exceeded. Now, what will happen is this. This deformation force, or the applied force, is directly proportional to the what? Displacement, or the extent of the what? Deformation. So, in another way, we can say, according to Hooke's law, that F, which is the force, or the deformation force, is directly proportional to what? X. X is the displacement or the extent. So if you have a string and you suspend a load, this load is what? 8 watts kg. So if you remove this now, it will go back to its normal form. But if you add more, it will extend down more. So that means as the force is increasing, the displacement or the distance will do what? Increase. So that means F is directly proportional to what? X. So to remove this sign of proportionality, we introduce a constant. So F is equal to what? Kx. That means K is equal to what? F what? X. So if an initial force is applied, we call it F1, and it causes an extension, we call it S1. And if you apply another force that is higher than this or lower than this, we call it F2. It will also move down, taking a particular, have a displacement, because there's a direction. So it's not just a distance, it's not a displacement. In this direction, we call it what? X what? 2. So what it means is this, that if K is F over X, so the relationship between this F1 X1 and F2 X2 is simple. If K is F over X, what it implies that if K1 is F1 over X1, that means K2 will also be what? F2 over what? X1, 2. But this K is constant. K1 and K2 are the same thing. So what it implies is that F1, what it then implies is that F1 over what? X1 is equal to what? F2 over what? X2, which is equal to what? K. So we are not doing anything with K here. So let's concentrate on this one. F1 over X2, F1 over X1 is equal to what? F2 over what? X2. Now let's go back to the question. a string of length 5 meter. This is original what? Length of the what? String. It extended by what? 0.04. So this is what? The displacement F. X1 is what? The first displacement X1 is what? 0.04 meter. Now, what caused this displacement? A force caused this displacement, but the load is 0.8 kg. It moves in this direction. This is 0.8 what? Kg. Acceleration due to gravity is what? 10. So the force is 10. Is the weight now, which is what? The force here is the weight, which is what? Mg, which is what? 0.8 kilogram times what? Acceleration due to gravity, 10 meter what? Squared. 10 meter per second squared, which implies that this F here now is equal to what? 0.8. This time this is what? 8 what? Newton. So the force here now is what? 8 Newton. So F1, so let me clean up. So F1 here is what? 8 what? Newton. Let's continue. F2, how far will it extend if a force of 16 Newton is applied? So if we have F2 to be what? 16 what? Newton. What will be the displacement? We don't know. What will now be the how far it can go? What will be the displacement here? We don't know. We call it what? Is our x2? We don't know it. So let us now substitute all these things here and solve for what? X2. So we now have what? F1 is what? 8 Newton. All over what? X1 is what? 0.04 what? Meter. Is equal to what? Is equal to what? F2 is what? 16 Newton. All over X2, which is, we don't know X2. So we make X2 the subject of the formula. So X2 now is equal to what? We will cross multiply 0.04 meter times 16 Newton. All over what? All over what? 8 Newton. X2 is now equal to what? 8 Newton, we cancel 16 Newton. We have what? 2. 0.04 meters times 2. We have what? 0.08 meters. So if a force of 16 Newton is applied, the string will move down by what? 0.08 what? Meters. Thank you very much for your attention. Please subscribe to our YouTube channel. Click on the subscription button, red button. Click on it and click on the bell by the side, so that whenever we upload a new video, you'll be among the first people to get notified. Please like this video, share. God bless you.